All right, so 11.2, arithmetic sequences. Last class, we just did sequences and summation notation. So now we actually have a actual specific type of sequence that we'll discuss in this section. All right, so arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. And the difference between consecutive terms is called the common difference. All right. All right, so first exercise, write the first 6 terms of the arithmetic sequence in which a sub 1 is 6 and a sub n is going to be a sub n minus 1 minus 2. So that minus 2 is not a part of the notation for your term. So just like before, when we talked about last section, don't forget that if they give you a sub 1, that's your first term. So they gave us a sub 1 is equal to 6. So now a sub 2 is where our calculation actually starts. So you plug in 2 everywhere you see n, and that means that first term that will be in our calculation is a sub 1 because it's a sub 2 minus 1, so that'll be a sub 1, which all that means is we're taking the previous term and plugging it in. So 6 minus 2, which would be 4. First term 6, second term is 4, and we continue to go on with that pattern. So that's for the first 6 terms. I probably should have brought it down lower. All right, so a sub 4 do the same, and all we do is continue on with the pattern. And last one, a sub 6. So our first 6 terms, 6, 4, 2, 0, -2, and then -4.
Can you go back up to the top there for A1 again?
Right here.
Yes, thanks.
Mm-hmm. All right, anything else before we go to the general term of your arithmetic sequence? Oh, see somebody in the chat. Can you go back up to the very top notes? I joined late. Nope, you joined late. I was just messing with you. All right. This was the top. Just arithmetic sequences. Yep, not a problem. I was just messing with you. Let me know when you're ready to scroll. For me to scroll down a little. Okay. And that was the second definition. Not a problem. Not a problem. Hold on. My daughters are attacking each other. Hold on 1 second. All right. So, all right. So the general term of the arithmetic sequence, a sub n is equal to a sub 1 plus n minus 1 times d, where the a sub n is the nth term, a sub 1 is our first term, and d is the common difference. So if we want to find the general If we want to find it, whether it be nth term, whether it be eighth term, ninth term, whatever, we'll be able to use this formula right here if we have our first term and we have the common difference. All right. All right, so they want us to find the eighth term of the arithmetic sequence whose first term is 4 and common difference is -7. So we know a sub 1 is 4 and d is -7. So we look for a sub 8, our eighth term. And so if we plug it in, or plug in what we know into this formula right here, and I didn't write n is equal to 8. That's the eighth term. So a sub 1 is 4 plus 8 minus 1 times -7. This is a sub 1, this is n, and this is d. So that'll be 7 times -7, 4 plus -49, and that'll be -45. That'll be our eighth term. All right, questions on that last one before we go to the next one?
No.
All right, sounds good. Next one, we want to write the formula for the general term, in other words, the nth term of the arithmetic sequence. We have -2, 8, 18, 28, and so on. All right, so if we want to figure out what the common difference is, of course, we can just subtract. We can do a sub 2 minus a sub 1. Since it is an arithmetic sequence, that difference should be the same between all of your terms. And you can always check by subtracting the, another two terms and make sure you have the same common difference. But if we do 8 minus -2, that's going to be 10. So the common difference between each should be 10 for us. And you can see that with 18 minus 8 or 28 minus 18, and we have 10. And probably, just for note purposes, I'm going to erase that and do another color. So it's going to be the same thing, just when I go back and look, or if I have to share them. All right, like I said, so you can take any two consecutive terms, and that will give you that 10, or should give you the 10. So, but remember, that only works for your arithmetic sequences. All right. So remember, the formula is a sub n is equal to a1 plus a minus 1 times d. And of course, a sub 1 is that negative 2. That's our first term. So to figure out the general term, or the formula for the general term, plug in negative 2. We can leave n in there and then plug in 10. And simplify the expression. We can do our distribution. Combine your like terms. And a sub n should be 10n minus 12. All right, next thing, we're talking about the sum of the first n terms of an arithmetic sequence, S sub n. So the S sub n just represents the sum of the first n terms. All right, so let's do an example that will help us out. All right, so we're going to find the sum of the first 100 terms of the arithmetic sequence. Got 1, 3, 5, 7, and so on. So basically, we want to find the sum of the first odd numbers, first set of odd numbers, first 100 odd numbers. Let's say it like that. Say it better. First 100 odd numbers. All right. So when we look at what we need, we're looking at this formula right here. So we're talking about S sub 100. N is 100 because we're looking for n terms. 100 terms. And then A sub 1. That's going to be A sub 1 for us. So we do this is N. So it'll be 1. But we need A sub 100. So we need to find this. So we almost had everything we needed. All right. So we need to find the general formula of the sequence. So remember, we find the general formula, then we can just plug in 100 to find the 100th term. So we go back to what it means to find the general formula. That's A sub n equal to A sub 1 plus n minus 1 times d. All right. So common difference. A sub 2 minus A sub 1. Just talking about 3 minus 1, which is 2. I know right now we know what the terms that we have. That's easy to see. But just going through the formality so that we see something that's more complicated or more involved, you know the process. And we already know what n and A sub 1 is. So A sub n is going to be 1 plus 100 minus 1 times 2. 1 plus, hold on. I want to do that right in the general. Yeah, I might as well. Let's go ahead and go to 100. Yep. So A sub 100 is going to be 1 plus 100 minus 1 times 2. Remember that formula? Let me write that one up here. A sub n is A sub 1 plus n minus 1 times d. So that's what we are using now. So A sub 100, 1 plus 100 minus 1 times 2. So that's 99 times 2. 1 plus 198. So that should be 199. So A sub 100 is 199. All right, so it's 199. And so remember, that's all we needed was A sub 100. So we can go ahead and plug it into this now. So we're looking at S sub 100, that's 100 over 2. And then A sub 1 plus 199. I think that's all we needed. Yep. So that's going to be 100 over 2 times 200. And that's going to be 100 times 100, which is 10,000. All right. Questions.
I've got nothing.
All right. It's always a great thing. All right, so I think there's one other example here that they mentioned. Of course, if you guys get in the homework and see some things that I may have missed, let me know. You always do it. All right, so it says find the following sum. We have a summation of 5 minus 9, going from 1 to 25. All right, so let's see. If we start this off, what we don't want to have to do is do all 25 terms if we don't have to. I'll do this like this. So it'll be 5 minus 9, which is negative 4. 10 minus 9, which is 1. 15 minus 9, 6. And then that's 125. Minus 9, which is 116. Yep. All right, so that's what we're looking at so far. All right. So they didn't mention, let's see. We can find our common difference once again, or establish that we do have an arithmetic sequence. So remember the last formula that we looked at, the sum of the first n terms of an arithmetic sequence. We can't use that unless it's an arithmetic sequence. One of the key things, or the main key thing about an arithmetic sequence is that there's a common difference between each term. And so you want to evaluate that, when we look at our common difference. You take a sub 2 minus a sub 1. So it's going to be negative 4 minus 1, which is a negative 5. If we were to do it again, let's say we do a sub 2 minus, I wrote them in the wrong way, that order, didn't I? Positive 5. Then do the same thing here, a sub 3 minus a sub 2, be 6 minus 1, which is 5 again. So our common difference is going to be 5 in this case, letting us know that we have an arithmetic sequence. So if we have an arithmetic sequence, we can actually go and use that summation formula, in which we're talking about sum of 25, the first 25 terms, in which that'll be 25 over 2. And then that first term, a sub 1 is negative 4, plus the last term. And we're looking at negative 4 here, and then 116 for that 25th term. So 25 over 2, 112. And then simplify that, that'll be 1400. So once you establish you actually have a arithmetic sequence, then you can use that formula, as long as you know the first term and the last term. All right. All right. Questions on arithmetic sequences? Anything, anybody?
No.
Sounds good. Yep. Let me see. Somebody said something in the chat. I was hoping that you guys would like this a little better than what we've been going through. So with that being said, we have one more section left. As I said before, there's no real rush that we have to push and get 11.3 out of the way. 11.3 is geometric sequences and series. So we can do that on next class. Don't forget, next class will not come next week. Next week, I'm giving you completely off. But if you have any questions or concerns, you can always feel free to email me. Or if you want to meet in the Zoom as an individual, then you do have that as an option. We just got to line up our schedules, make sure that we both can do it. I don't have a problem doing that. As long as you're not trying to hit me on Thanksgiving, then, we try to give you a little leeway on that one. And so, like I said, when it comes to this week, trying to give you guys a chance to, either get caught up or take advantage of the opportunity of trying to figure out this Thanksgiving thing. I know some people have a lot of moving parts when it comes to this, especially with what's going on in our society today. So I'll give you that time to get things straight. So I will see you guys again back on December, I think, 1st, December 1st, Tuesday, December 1st. Once again, though, if you need help, always feel free to email me, and we'll make that happen.
Do you have the what last chapter's test review or quiz
I didn't post that.
review? I don't. I can see it. If I keep scrolling down,
You know
I think
what?
that's it down there. But
I will check to make sure. I think you might be trying to save me a little bit, saying you think that's it down there. I think you probably know that it's not it. I'll check to make sure. If that's what you're doing, I appreciate the save, appreciate the cover. I forgot whether I did or not. Well, normally when I forget whether I did or not, that means I probably didn't do it. Apologize. I will get that in there today, ASAP. Get that in there today.
oh, that's all right. I'm just trying to move along, is all.
So, anything else? You know what? I'm going to confirm. Let me confirm that right now because I want to know if I put that in there. I hope I did, but I don't remember doing it.
I mean, at the top when I go and test and quizzes up at the top, all I see is test 1 and test 2. I don't see anything else.
Right. So I know I hadn't posted the test, but I was hoping I at least did the review. 162.
You said you posted the test?
No, I said I knew I hadn't posted the test.
Oh, okay.
I was hoping I at least.
I hadn't seen that one either.
I was hoping I at least posted a review, and with everything that's been going on, I wouldn't be surprised if it's not there. If I hadn't posted it yet. Yep, I haven't posted it, so I'll get that in there tonight. By the end of the night, I should say.
Thank you.
All right, no problem. Thank you for the reminder. So outside of that, you guys have a great weekend, have a great holiday, and I will see you officially back on December 1st. December 1st. All right.
Take care. Happy Turkey Day.
Thanks. Same to you.